Hello everyone, welcome back to the channel. My name is Teacher Samuel, and today we have a circular catch-up problem. Now, this problem comes from an NMOS past year exam, and it is a particularly difficult question. So let's take a look at it together. The question is as such. Aaron and Brian are walking along a circular track with center O. So the center here is O. AOC and BOD are diameters of the track. So we have AOC and BOD over here as diameters of the track. It takes Aaron 8 minutes and Brian 12 minutes respectively to complete walking one round of the track. If Aaron starts walking at point A over here and Brian starts walking at point B over here at the same time, and they both walk in a clockwise direction, so like this, how long in minutes will it take Aaron to catch up with Brian? Now, you might be looking at this and thinking, oh no, this is very difficult because there's so much information and we have two people at two different places. But not to worry. Let's take a look first at a simple and fun example. So, in this example, let's say we also have here a circular track. And let's say that at this starting point, so over here, we have two characters. You may be familiar with them. One of them is Teacher Jang, and the second character is Teacher Samuel, so myself, teachers here at Kangaroo Study. Now, let's say that both of us are cycling on bicycles around this circular track. And because Teacher Jang, let's say, is very fit, so he is cycling at a speed of 30 meters per second. And myself fit, but not as fit. So, I'm traveling, let's say, at 20 meters per second. And let's say that both of us are from this starting position traveling in a clockwise direction, and the length of this circular track is 400 meters. And the question I want to ask you is, how long would it take for Teacher Jang to catch up to me? You might be wondering, how do we know that Teacher Jang catches up to me? Well, the answer is simple. We know Teacher Jang catches up to me in this example simply because Teacher Jang is traveling at a faster speed compared to me. So, let's just say that as an example, I, myself, Teacher Samuel, travel this distance over here, represented by this solid black arrow. And let's say at this point over here, Teacher Jang catches up to me. So, how would we express the distance Teacher Jang traveled? That's right, we could express it like this dotted black arrow. And so over here, this is the catch-up point where Teacher Jang catches up to me. And so you see here that Teacher Jang travels one whole round more than me as he catches up to me. So, how do we now determine how long it takes for Teacher Jang to catch up to me? Well, first, we have to consider, in 1 second, how many more meters does Teacher Jang travel compared to me? Now, the answer is simple. We can just take the speed difference, so 30 minus 20 equals 10 meters per second. So in 1 second, Teacher Jang travels 10 meters more than me. Now, I want to ask a very important question. How many more meters does Teacher Jang travel compared to me? Well, we can see in the picture that Teacher Jang travels one round, this distance, more than me. And so, how many meters more does Teacher Jang travel? It's represented by this purple line, and so it is 400 meters. This is a very important point. We know that Teacher Jang travels 400 meters more than me, Teacher Samuel. And so, how do we calculate how long it takes for Teacher Jang to catch up to me? We take this very important concept, 400 meters more Teacher Jang travels compared to me, and divide it by 10, which is how many meters Teacher Jang travels more per 1 second. So we can get that Teacher Jang takes 40 seconds to catch up to me. Now, this kind of problem we can solve with this formula, distance difference, which is 400 meters, divided by the speed difference, which is 10, which will get us our time of 40 seconds. And this problem, we can call it a circular runway catch-up problem. And what is the very, very important point in this example? That's right. It is very, very important to remember that the distance difference in this case, since both Teacher Zhang and myself, Teacher Samuel, start from the same point, the distance difference is the distance of one round, which in this case is 400 meters. And now that we're done with this fun example, let's go back to our question. So, this is the model in our question. And if you remember, the information states that Aaron takes 8 minutes to travel one round and Brian takes 12 minutes to travel one round. Now, we are being asked how long does it take for Aaron to catch up to Brian? So, students, how do we solve this? First, we can consider the formula time equals distance difference divided by speed difference, the same formula as we had in the example. But let's see, how do we find over here distance difference? How do we find distance difference? First, what we can do is we can assume the distances that Brian and Aaron are drawing visually. So, for example, we can say that Brian, let's say, we don't know for sure, but let's say Brian travels the length of this solid black arrow, and let's say over here is where Aaron catches up, which means how would we express Aaron's distance traveled? Like this dotted black arrow over here to get that catch-up point. So let's just say, as an example, that Brian travels this solid black arrow and Aaron travels this dotted black arrow to this catch-up point over here. So, how would we express distance difference over here? That's right. It can be expressed as this red arrow over here. And how do we express this red arrow? The only way we can express it for now is in relation to the perimeter, which is very good, 1/4 of the perimeter. So, let's think. If we want to use this formula, we need to get a numerical value for the distance difference. And how do we do that? Since the question does not give us how many meters the circular track is. We can set the perimeter in terms of units. Now, this is a very, very important question. How many units should we set the perimeter of this circular track as? Well, remember, we still need to calculate speed difference, which means we need to incorporate the times given in the question. So, to make it easier for us, what might we use as the units for the perimeter? We can use the lowest common multiple of the time. So, what is the lowest common multiple of 8 and 12? It would be 24. And so, we can set the perimeter of this track as 24 units. And then, how do we now calculate the distance difference? We can just take the perimeter of 24 units divided by 4, since the perimeter, or rather, the distance difference is 1/4 of the perimeter, which means that the distance difference is 6 units. And now, what would the next step be after we have our distance difference? That's right, we need to find our speed difference. And how do we do that? We would need to calculate the speeds of Aaron and Brian separately. So, let's say that we need to calculate Aaron's speed. Of course, you can start with Brian's speed, whichever one you prefer. I will start with Aaron. So, with Aaron's speed, how do we calculate Aaron's speed? That's right, we take the distance he travels divided by the time it takes to travel that distance. So 24 units divided by 8 to get 3 unit meters per minute. And how do we calculate Brian's speed? We take the distance he would travel if he traveled one circle divided by the time it would take for him to travel that. So 24 units divided by 12 is 2 unit meters per minute. Now, what is the next step then to solving this problem? Of course, we can use the formula over here. time equals distance difference divided by speed difference. And let's think about it logically too. Let's say, what is the distance difference? Meaning, how much more distance does the faster person, Aaron in this case, travel? How many units? 6 units more. So, Aaron travels 6 units more than Brian. And let's think, in 1 minute, which is the unit of time we are considering here, in 1 minute, how many units more does Aaron travel compared to Brian? It would be 3 minus 2, so 1 unit more. And so that's how we think about the problem logically. And we can also use the formula which goes hand in hand with this logic. So how do we solve for the time here it takes for Aaron to catch up with Brian? That's right, we take the distance difference, which is 6 units, and divide it by the speed difference, 3 units minus 2 units. Again, how we do this, or think about it logically, is 6 units is the distance more that Aaron traveled compared to Brian. And 3u minus 2u, what does this represent? It represents how much more Aaron travels in 1 minute, which is 1 unit. And so what is the time it takes for Aaron to catch up with Brian? Of course, it would be 6 minutes. So, now that we have done this question, let's summarize it really quickly. So, in this example, what we have is a circular runway catch-up problem. Now, what is the formula we use to solve a problem like this? Of course, it would be time equals distance difference divided by speed difference. And what's another important point about this example? We don't have distance given. And so how do we set the perimeter? To make it easier, we can set the perimeter distance in units as lowest common multiple of both persons' time. That way it is easier to calculate speed difference. So thank you so much for watching today. If you have any questions, you can scan the QR code on the left to contact me, or you can scan the QR code on the right to join our Primary 4 study group. Thank you today for watching. Happy studying and see you in the next video.